Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS8602, Compiler Design, Unit 4, topic Access to Non-Local Data on the Stack. Access to non-local data on the stack. Access becomes more complicated in languages where procedures can be declared inside other procedures. Let us consider the simple case of C functions and then language, machine language, that permits both nested function declaration and functions as first-class object. That is, functions can take functions as arguments and return functions as values. Next, we are going to see data access without nested procedures. That means a global variables has a scope consisting of all the functions that follow the declaration of V, except when there is a local definition of the identifier V. That means here the variables declared within a function has a scope consisting of that function only or part of it. Here we have two conditions. The first condition, global variables are allocated static storage. The location of these variables remain fixed and are known at compile time. So, to access any variable that is not local to the currently executing procedure, we simply use the statically determined address. The next condition is any other name must be local to the activation at the top of the stack. These variables can be accessed through the top _sp pointer of the stack. The next one is issues with nested procedures. The access is more complicated if the language allows nested procedures and uses the normal static scoping rule. That means it is that knowing at compile time that the declaration of P is immediately nested within Q does not tell us the relative positions of their activation records at runtime. In fact, since either P or Q or both may be recursive, there may be several activation records of Q or Q on the stack. The next one is access link. A direct implementation of the normal static scope rule for nested function is obtained by adding a pointer called the access link to each activation record. That means if procedure P is nested immediately within procedure Q in the source code, then the access link in any activation of P points to the most recent activation of Q. The nesting depth of the Q must be exactly one less than the nesting depth of P. Access link form a chain from the activation record at the top of the stack to a lower nesting depth. Along this chain are all the activations whose data and procedures are accessible to the currently executing procedure. Then next we are going to see the access link example diagram. Using this access link, when a procedure P is placed to another procedure Q as a parameter and Q then calls its parameter, that means therefore calls P in the activation of Q, it is possible that Q does not know the context in which P appears in the program. If so, it is impossible for Q to know how to set the access link for P. The solution to this problem is as follows. When procedures are used as parameters, the caller needs to pass, along with the name of the procedure parameter, the proper access link for that parameter. Then access link for the procedure parameters means here it is used as a parameter. The caller needs to pass along with the name of the procedure parameter the proper access link for that parameter. Thank you.